So in this case, we are going to have a continuation working with our parabola as we had in our previous class. So if you are to consider this time, we have a different situation in terms of the presentation. The presentation that we are seeing here is different from what we had before. Remember, we had our function of y is equal to ax squared plus bx plus c. It is a quadratic function indeed. All right. And in that, we talked about sketching this, determining the y-intercept, the x-intercepts, the turning point, and also to sketch. That is the same situation with this function. If you are to notice what we are seeing here on this part, remember our identities. So I'm just going to explain this before I move into this function. Remember your identities when you had this a minus b squared, which is equal to a squared minus 2ab plus what? Plus b squared. This is a quadratic. If you square this, you're going to form a quadratic. Meaning to say, if you're given something of this nature, maybe it is 2 into x minus 3 squared plus 4, whatever that you're going to have after squaring, the x is going to be raised to the exponent of 2. So it will be x squared. By having x squared, that's a quadratic, the exponent, the highest exponent on x is what is 2. So that's a quadratic function. That's a parabola. So that is the condition that you are simply having there. So in this case, when you are having this format, this is from your grade 11 mathematics. Remember, in grade 11, we work with the completing of the square. When you completed the square, this is what you ended up with, the format, which can be given differently. It can differ with your textbook. You can have it like this. They can use positive throughout like that. All right. It's a format which simply shows us the turning point. This is the turning point concept. All right. Where this part that is inside the bracket, take note, the part that is inside the bracket is the one that is important, that I want you to be very, very careful with. This part, x minus p, this part is important. You are going to equate that part to 0. It shows the turning point concept. You equate that x minus p to 0, meaning to say x will be equal to p at the turning point. So it simply gives us the turning point concept to say the point p and this q, which represents the y value as it is, the q is not affected. You take it as it is. So pq becomes our turning point, this one. So you equate this one to 0. All right. So if you are given with a plus like this, it differs, like I said, with your textbook. If you are given it in this way, if you equate this to 0, all right, it follows that x will be equal to minus p. So therefore, minus p versus q, which is the y value, is our turning point. This one, minus p versus q, becomes our turning point. So in simple terms, we just equate the bracket to 0. All right? Or just change the sign. If there is a minus here, this one will be a positive. If there is a positive here, when you are writing it as a turning point, it will carry a negative. Or you equate the bracket to 0. That's the most important part. That's the form. This format, that is what it represents. There is no need for you to expand the brackets when you are to sketch this function. There is no need for you to expand. You can simply take your turning point that way. So when you are to sketch now, how can you sketch? Remember, we are on sketching. We want to sketch this function just like what you had before when you had a quadratic, when you were having y is equal to x squared minus 5x minus 6. It was a quadratic. These points, they still work in sketching even a quadratic function in that manner. Writing down the y-intercept where x is equal to 0, still the same part. Calculating of the x-intercepts, remember, y is supposed to be equal to 0, and also determining of what? Of the turning point. This time, the turning point is already given from what? From the function. The only thing that we need is the x-intercepts and the y-intercept. That is the only part that we need there. But otherwise, you can see that the turning point will be given automatically from what? From the function, the way it will be given there. For an example, let us say you are given to sketch, all right? You need to sketch this a quadratic function, sketch the function, all right? Or the graph of y is equal to, all right? So let's say we are given this as x minus 2 squared, x minus 2 squared minus 1. All right. So given a function, given it in this manner, you're asked to sketch. Remember, I said the turning point is already presented from what? From the presentation of our function, we can have the turning point already. All right. But let's say, okay, we're going to talk of the turning point later on. Let's just move on stage by stage. The y-intercept, all right? So we're going to talk of the y-intercept. Remember, the y-intercept, it's on a condition where x is equal to 0. This one does not change. So you simply substitute a 0 into the equation as it is in place of x. That's 0 minus 2 raised to the exponent of 2 minus 1, which you can simply use your calculator to evaluate or to simplify this one. All right. So in this case, let me just try do this so that we can have our calculator. So just open a bracket as it is. That's 0 minus 2. Close the bracket. You square it minus 1. So that is going to give us a 3. All right. So the y-intercept is on a condition where y is equal to what? Y is equal to 3. When x is equal to what? When x is equal to 0. So just like what we had before, we also calculated the x-intercepts. All right. And I said for the x-intercepts, all right, for the x-intercepts, we are going to use the condition where y is equal to 0 and we solve the equation that is the equation that you formulate, which is the quadratic equation. So we are going to formulate a quadratic equation by letting y to be equal to 0. So meaning to say this whole part will be equal to what? To a 0 as it is. So we're going to take this x minus 2 squared minus 1 is equal to 0. All right. Remember y is equal to 0. Then you have to solve for x. You have formed an equation, remember? Which is a quadratic equation where the highest exponent is 2. But how do you solve this? Are we going to expand the brackets? Then we start to factorize this and that. Guys, if you have that time, then do it. And the time management is in your hands. But we can simply take the minus 1 to the other side. Remember, it's a square. There's a square there. So that we introduce the square root. So take the minus 1 to the other side so that it will be what? A positive 1. So that's x minus 2 squared is equal to negative 1 to the other side. That's a positive 1. Introducing the square root to get rid of this square. So you're going to introduce the square root both sides. That's eliminating the square. So you remain with what is under the bracket. This one, the x minus 2. So that is the part that you are going to have at the end. Remember, we are eliminating that. The purpose there is to get rid of the 2. So it is going to be x minus 2 equal to what? Knowing that the square root of any number is plus or minus. So that's plus or minus 1. All right. So let us solve for x by taking the minus 2 to the other side of the equation so that it will be what? A positive 2. It was a negative. So it is going to be a positive 2, meaning to say we have got two solutions, the plus 1 and the plus 2. So that's 1 plus 2, or x is going to be what? The minus 1 and the plus 2. So we're going to have minus 1 plus 2. Minus 1 plus 2. So that's it, guys. X is going to give us 3, or our x is going to be what? Positive 1. Minus 1 plus 2, that's a positive 1. If we are to Subtract 2 minus 1, guys. That's the 1. All right. So that is you're having the x-intercepts. These are the x values when y is equal to 0. All right. Then we also referred to the turning point. So we're going to move on to the turning point. All right. So the other part is our turning point. And as we have referred from the format this time, the format here tells us if we are given this one, the turning point is given as PQ. So meaning to say we have got minus 2 like this. We are going to take this one. It will be a positive 2. The negative 1 remains as it is. Remember, the y value, Q. If it is Q, it remains as Q. If it is Q here, it remains as Q. It does not change. It is the X which changes, the X value. Or like I said, equate this bracket to 0. Just like that, X minus 2 is equal to 0. So what is the X value? Minus 2 to the other side, that's a positive. 0 plus 2, which is 2. So you can have it that way. All right? That's our turning point. So the turning point is already there from the equation, from the function. This time we've got the advantage of the function. We don't need to say what is going to be the x for this, x of symmetry, this and what, guys. No. 2 minus 1. That's our turning point. With this information is the same as what we had before here. Same information, like calculating of this and that. So meaning to say, we can have a sketch from this, right? So I'm just going to have a simple sketch here, all right? So let us have our axis, which is the x-axis and the y-axis, all right? So let's say that is our 0 there. Remember what is important. All right, the other thing is the shape, all right? We are going to need the shape because everything is there. All right, the x, y-intercept, this and that, turning point, everything is there. All right, we also need the shape. So as for the shape, this is what is going to happen. You are going to notice that the number which is affecting the bracket here is going to affect our function here. Remember, guys, if you are given x, maybe even if it is minus x inside here, the moment you square it, it is going to be what? A positive. So the number that will be outside is going to affect, let's say there was a number like minus 2. After you obtain x squared, it will be multiplied by a negative 2. So that is why I'm saying that number is going to affect. So at the end, it will be like minus 2x squared. So in this case, if you are to consider the number that is outside is just like 1. Outside of the bracket, there's a 1. Just like this is our A. Our A affects this one. That is outside of the bracket. This A here. This one, outside of the bracket. That A affects the same concept as what we had when we are having a normal function. When A is greater than 0, we are going to have what? A positive, which is a smiley shape like this. All right. For A, which is less than 0, which is a negative, we are going to have a set shape, which is what? Which is like this. So that is the condition that you are going to have at the end. As we had before. So in this case, we have got our A as what? As 1. Our A is equal to 1. So if our A is equal to 1, that means we are talking about a value which is greater than 0. So you're going to have what? A smiley shape like this, which is concave up. Okay, that's about the shape. All right, guys, no problem. Let us consider our intercepts. Remember our x-intercepts. They are both positive. Positive 1, positive 3. They are both positive, all right? So let us just mark our points. Let us just say this is where we have our positive 1. Let us say this is where we have our positive 3. Okay, these are the intercepts. Then we have got the y-intercept, positive 3. All right, the y value, positive 3. So let's just say this is where we have the y value at positive 3, approximately going up like 0, 1, 2. So this is where we have got positive 3, 0, 1, 2, like that. All right. So let's say this is where we have our positive 3. Then we talk of the intercept, this y-intercept, we referred it. All right. Then we move on to the turning point. So this one, we referred this, we referred this. So now the turning point 2 minus 1. All right. That's our turning point when x is 2, y is minus 1, minus 1, minus 2, and so on. So 2 in x versus minus 1, that's somewhere here. All right. So we are going to have our point 2 minus 1 somewhere there. That's our turning point. So from there, we can have our sketch. All right. So we can just have our sketch this way. All right. So we need to pass through these 3. Okay. Pardon my sketch, guys. Pardon my sketch. This is freehand, remember? All right. To the turning point, which is 2 versus minus 1. This is a turning point. So it's supposed to show like a turning point that we are going to have a curve. This is a curve like something like this. All right. Then it goes back up like that. So we're going to have something of that nature. Okay. So that is our function. That is our function. What is important is to indicate the x-intercepts, the y-intercept, the turning point. So that's it. This is our turning point. Remember, our turning point is at 2 versus minus 1. When x is 2, y is minus 1. So that's our turning point there. All right. So that's our function, which is the graph of y is equal to, all right, it was x minus 2 squared minus 1. So we just have to write our function. Y is equal to x minus 2 squared minus 1. Just like that. Just like that. All right. So this is to sketch. You are given the equation, the format there is important. Format on its own is important. So I want us to try as many questions. It is going to help you guys in preparing yourselves. It is going to be very, very important that you do try as many questions as you can. I'm just going to have a simpler one so that we finish up. All right, let us just have another one, just simple, so that we just get the idea. But after this, can you do as many questions where there's a challenge? The comment section, guys, that's the purpose of it. Let's communicate. Let me understand if you've got a question that is challenging so that we can work that question together on this platform. All right. Still on sketching the functions, we are given to sketch the function. This time, let us say we are given y is equal to minus 2 into x plus 1 squared. Okay, let us say we are given something like this. All right. So just like what we had before, we are going to need the x-intercepts, this and that, y-intercept, this and that. All right. So that's it. Let us start with the y-intercept. The y-intercept, which is on a condition where x is equal to 0. So you just have to substitute in place of x, you put a 0 there. So that's y is equal to minus 2, open bracket, in place of x, you put a 0. So that's 0 plus 1 squared, of which 0 plus 1, guys, that's a 1. Okay, and 1 squared is 1. So times minus 2, y is minus 2. Or just use your calculator. All right. After that, we are going to need the x-intercepts. All right. We are going to need the x-intercepts, which is on a condition where y is equal to 0, like I explained before. That's a condition where y is equal to 0. So equate these two to 0. Minus 2 into x plus 1 squared is equal to 0. That's an equation to be solved. All right. So get rid of the negative 2. It's just a product that we are seeing there. So simply divide by negative 2. We are allowed, because it's an equation, there's an equal to. This is equal to this. So whatever that you do on the left-hand side can be done on the right-hand side. All right, so let's get rid of this. So we are going to remain with a bracket squared. That's x plus 1 being squared is equal to what? 0 divided by -2, that's a 0. All right, you can even use your calculator if you're not sure about that. So that's it. Let us obtain x values like we had before, introducing the square root to remove this square. So we're going to introduce the square root both sides. So that's x plus 1 is equal. Can we say plus or minus 0? Right, we cannot have that, guys. 0 is just a 0. Plus 0 minus 0, just one and the same. So that's a 0 there. All right, so take the 1 to the other side. It was going to give us a negative. So that's -1. So x is equal to 0 minus 1, which is what? Minus 1. Remember this. It's a quadratic equation. The highest exponent is 2. So you're supposed to have two solutions. That is the plus or minus 0 that we neglected there. Guys, there are two solutions, but we are obtaining one solution. Why? Type of the equation that we had. But know that this minus 1, it represents two values. It is like this. It is like we're supposed to have two values. Say x is equal to -1 or x is equal to -1. There are two values representing the same number. -1 and -1. Just the same solution. Is the same solution. That is what it actually means, this one. Remember, it's a quadratic. When you solve for x, you must have two values. A linear, when you solve for x, you must have one value. So when there's one value like this, know that it was just same value repeating itself. All right. So that's it. Let's move on to the turning point. Remember, you also need the turning point. So you're going to need the turning point. So the turning point, like I said, we can simply get it from the format. If we are given this, there's a bracket, as we can see here. Do not worry about this -2 that is outside of the bracket. All right. This is the A that we are seeing. It is not affecting our turning point at all. No, it does not affect. So meaning to say, therefore, our turning point, what is going to happen with 1? Remember, it changes to a minus. So it was going to be -1. What about here? We are not having anything like what we had before. We are not adding a 5. We are not subtracting anything. So which number are we having? It is just like there's a +0 or there's a -0. Remember, 0 I said it can be plus or minus. It's just a 0. So the number there is for y is what? Is a 0. If the number is not given there, it means that's a 0. So that's our turning point. Remember this, guys. If you have forgotten, I said just equate the bracket. X plus 1, you equate it to 0. Then you solve for x. So x is equal to what? 1 to the other side will give us a -1. So that's our turning point from the format of the function, the equation that you're given already. You're given the format. So that's, we have a turning point there. -1 versus 0. Our turning point is there. All right. Then on sketching, I said we also need to know the shape. The shape is determined by A, the number that is outside of the bracket, because as you expand the bracket, X will be a positive. But the number now determines whatever that you have outside there, because it is going to multiply that X squared. So outside here, what are we having? We are having a negative. Outside of the bracket here, the number that is outside, that's a -2. So if A is a negative, like what we are seeing, that A is -2, it's a number which is less than 0. Less than 0, so you're going to have a Z shape like this, concave down, facing down. All right, so that's our shape. So let us have our sketch and see. This information, it must play a role to have our sketch. So this is the condition. Remember that in this graph or in this function that we are going to have, the x-intercept is at 1 point. They were supposed to be two values, but it's at 1 point. So I'm going to show you how to draw that one. All right. This is it. -1 is our x-intercept. So let us just say this is -1, -2, 1, 2, 3, and so on. So this is -1 is our x-intercept. When a point is repeating, that point which represents our x-intercept, it is also a turning point. It is also a turning point. That point will be a turning point. Okay, let's see. Let's go to the turning point. Look at the turning point. The turning point is where? -1 is 0. Exactly where we have our solution, which is our x-intercept. That is the condition when it repeats like that. X is equal to 2 or x is equal to 2. That point becomes x-intercept and the turning point at the same time. So you have to be careful. All right. So this here is our solution, also our turning point. So let's go to the y-intercept. Remember, y-intercept at -2. All right. We took this. So we took this. We need y-intercept at -2. All right. So let us just have -1, -2. So that's our y-intercept at -2 like this. How are we going to sketch our graph? Remember, I said A, the value of A outside of the bracket there, we saw that A is -2. So we are going to have it concave down, a Z shape like that. All right. So our shape from our graph is supposed to be like this. Remember, our shape is supposed to be like this. So meaning to say from the y-intercept going to the what? To the x-intercept. It was supposed to go to the x-intercept, then pass like this. But it is not going to happen like that because that x-intercept is also a turning point. So as the graph is going to meet this point at the point -1, which is a 10, which is your x-intercept, it is going to curve at that point. We are going to have it going back like that because it is also a turning point. All right. So let me just try to have a proper sketch. But guys, you can just have, this is just a sketch, guys. I hope you are understanding me here. So here, as for me, guys, you see I'm using these softwares. I cannot have exactly the part, but it's just going to be like this. All right. So this is what we have. The x-intercept became the turning point as well. So it can happen like that. We can have this. Those are the most of the curve that we had in our grade 10 mathematics when the turning point was at the origin like this. It goes to the origin, then it goes back like that. That point, it was your x-intercept, and it was also the turning point at the same time. So it can happen. Some functions can be like that. All right. So what is important? Know the shape. How is the graph going to look like? The shape. So in this case, it is concave down. So let us try to work out as many questions as we can. Like I said, try to figure out on this typical type of a question. How are they going to ask the questions so that it can help you in your revisions? But these are the basics. What you need is the y-intercept, x-intercepts, a turning point. With this information, your function can be sketched or you can draw your function. So that is it, guys. Till we meet again.